Alright guys, so today we're going to sit and discuss a very simplified version of equine color genetics in the Percheron draft horse. I'm trying to simplify this as much as possible, so for you ladies who are heavily into the equine color genetics, even more so than I, don't be too critical on this. I'm trying to make it as easy as possible for people to understand. So we will start here. Let me go back just a moment. I know it's here, it's just a matter of finding it. All programs. Hang on a minute, guys. Paint tool, SI. Alright, so we are going to open up a new sheet, and I am going to use this program to help me show you guys visually what we're looking at. To start this out, let's go over here, let's make it a 12, grab a pen, and we're going to do this in red. Okay, there are two ends of the spectrum to all horses. There is black. Well, that's definitely not big enough. We're definitely going to need something bigger than that. Oh, well, we clicked the wrong one, that's why. Okay, there is black, and there's this beautiful little line, and we are going to have the opposite end of the spectrum, which we call chestnut or sorrel, depending on location. I have always learned it as chestnut, but to each their own. I know a lot of your Percheron people do call them sorrels, and it has to do with the shade of the red horse, but we are just going to call them red. Let's simplify it. Black and red. So these are the two ends of our spectrum here that we're dealing with. Notably, when you're discussing black and red in horses, it's based on what we call alleles. The black allele is defined as a big capital E. It is a dominant allele, which means that when it is present, it cannot be overridden by a recessive allele, which is red. Red is identified as a lowercase e. All Percherons contain, obviously, it's just like people, it's just like anything. Everything gets a DNA copy from each parent, from the male and the female. Same thing in horses, so there's two sets of genes to everything. So, for example, some of your Percherons are homozygous black. Let's take Ace, for example. Many of you know the stallion that I'm talking about. Ace is homozygous black, meaning that Ace carries what is a copy of two big E genes. He is homozygous black. Every time he throws either one of these genes, it does not matter which, he is going to contribute black to his foals. He cannot produce red foals because he does not contain a little recessive E allele. Now, but when I take him to, let's say, a mare like Bambi, for example, Bambi, which is Hector's mom, she is a bay mare, but we're going to simplify this down for a second, ignoring the fact that she is bay. Her red factor, which is what this involves right here, big E, little e, red factor, her test came back telling me that she is obviously, logically, she carries one large copy of black, because to be bay, you have to have a base coat of black. These are what this is. This is base coat. Base coat is black, base coat red. But she carries a hidden recessive little e, a little recessive allele. So every time we breed Bambi, here's Bambi, to our boy Ace, we have this chance of getting red carrying foals. So this was one of the reasons, like when Hector was born, that I tested Hector to find out if he carried a red gene. You guys have probably seen Punnett squares. This was something that was introduced when I was in my freshman year of high school in biology. We only had ours for a quarter semester, but I loved biology, so I ended up taking 2 more years of advanced biology. But we're going to use this simple Punnett square to show, and this is what's going to explain to you. Okay, so we're getting a copy of E from Ace. In this quarter, we're getting a copy of E from Bambi, but it's got to be the big E. And then we go across the way. Ace is throwing his big E on this one, but Bambi is throwing her little E on this baby. Again, big copy, blend it down, you have big E from Ace, big E from Bambi, and again, big E from Ace, and little e from Bambi. This means that in this 25%, 25%, 25%, 25%, this tells you right here, 50% chance of all foals between Bambi and Ace are homozygous black. That means those foals will come out as big E, just like their sire, just like Ace, because they got a black gene from both parents. So 50% of their foals, 50% of each foal, I shouldn't say 50% of foals. That confuses people. That's where people get confused. It's not that 50% of all their babies will be black and 50% will be red carriers. No. Each pairing has a 50% chance of being homozygous black or what is called heterozygous. So we'll have a 50% chance with each foal of being a red carrier. Now, when you involve things like A, which stands for agouti, Bambi for example, again, Bambi's parents, we're going to take Bambi's parents, okay? We're going to simplify this down. We're not going to do the red factor. We're not going to do the black or the red of her parents, but we are going to do the bay of her parents. I know for a fact that Bambi's sire, oops, funny name, huh? Oops, who was a bay, his sire was black. His sire was Ebony of Glenlee. Ebony of Glenlee was black. He did not give Oops an agouti gene. Agouti is what we call bay, okay? So we're going to put a little a right here. So that means it's recessive. That means he does not have it. But his dam, which was, if I remember right, Crystal Montcarlayette, Sprucedale, Crystal Montcarlayette, she was a Canadian mare. She gave Oops an agouti gene, so he gets a capital dominant A. Now Bambi's dam, who was a daughter of Oops, and out of the mare Shady Lane Bertha, also bay, we're just going to guess here, okay? We're just going to say for posterity's sake that Bambi's dam got a bay gene from both her sire Oops and her dam Bertha. Now for some ungodly reason I can never remember Bambi's mom's name. It's one of those kind of names. Anyways, so each time that Oops was bred to Bambi's mom, which is a whole whopping total of twice, or maybe she was Bertha herself. Either way, she wasn't. No, she wasn't. She would get one copy of A here and a little copy of A here. So 50% agouti, no agouti. So we have a single agouti carrier. We have a heterozygous horse. Again, big copy A, little copy A. Two big copies. This is called homozygous. When a horse has two copies of the gene and will pass it on to every single foal, this is called homozygous. So again, we have a horse that we had a 50% chance of homozygous agouti, and we had a 50% chance of heterozygous. Now this is a mock-up of Bambi herself. Now what you need to know is that for me to figure this out, this is not something you can visually see. I had to send in hair to UC Davis, and UC Davis had to tell me whether Bambi herself carried two copies of bay / agouti, or whether she only carried one copy. When her test results came back, Bambi carried two copies of A. Homozygous bay is very rare. In fact, when I went through all the horses left in the breed, there were literally, let me see, three potential horses that could have been homozygous bay. And in other words, where they had bred at that time a bay stallion to a bay mare. Now, Bambi herself was incestuously bred, daughter back on sire. But what had happened is Jack had gathered up what few bays he could and had managed to find an outcross line. So in essence, by the time I got to the bay Percherons, Jack had already paired up the two lines. They were already mixed together. Bambi's Grand Dam being that other opposite line that was not from the Dam of Oops, was not from the Crystal Montcarlayat mare. And he had already paired them. Now, in most cases, he only got foals that were one copy A. They were heterozygous agouti, heterozygous bay horses. This is what most Percherons are. Most Percherons are heterozygous bay. Very rarely did people cross two bays together. It was just kind of happen chance that these horses passed along through the genetics and through the years. But this is an example, and this makes it pretty simplified. Going back here to our main part, which is talking about our dominant allele being black, E, capital E, our recessive allele being red, little e. This is the big focus for most Percheron people. Most Percheron people have black horses, black being the most common here in the United States. This is the big easy one for you guys, because this is what's important for you to know and to understand how red horses occur. And it also kind of explains in a way, as we get into the red portion here, which I'm going to explain, it explains to you how you can utilize a perfectly good red horse in your breeding program and still get really damn nice black foals. Red horses should not be thrown out solely because they are red. For example, like the mare that I had purchased, her name is Whiskey Tango Foxtrot. I bought Whiskey Tango, which is Foxy. I bought her 2 years ago in October, and I didn't care that she was red because it didn't matter. I have two homozygous E stallions. Both Ace and his son Hector are homozygous black stallions. They will produce nothing but black foals for me every time. Now, I know because Foxy herself, we know Foxy's not black. She can't be. If it was present, it has to show. This is a dominant gene. So for Foxy to carry black, she has to be black based. She's not. So that means she is automatically two copies of little e, little e. All red horses are little e, little e. Black horses are the only horse that can carry one of each or two black genes, okay? So when I picked up Foxy, for example, and we bred her to, say, Hector's homozygous, so we're going to have two copies of Big E. He's a homozygous stallion, and we know, without testing, that Foxy is little e, little e. You will see in our cute little Punnett square that is not perfectly square because my hands get a little shaky sometimes, that every foal, every pairing that they have is going to be 100% Big E, little e. That is just the way the genetics work when you breed a red mare to a homozygous black stallion. Every foal will carry a recessive red. But, again, it goes back to it. There's no reason you cannot use this red mare. Because you take that resulting foal, whichever 25% it is, it doesn't matter. They're Big E, little e. They are a black horse, or a black-based horse carrying a recessive hidden red, and it does hide. You can take that resulting foal, and as long as you breed this foal to a homozygous black stallion, a non-red carrying stallion, you will get and get away from this red gene. Because what happens is going back, like we had discussed before in the case of Bambi there, where you took and you bred this horse to a Big E, little e. This is your baby that you produced here, okay? and you're breeding her to a homozygous black stallion, now look at this. You have a 50% chance of all resulting foals being homozygous black again. You have now gotten away from the red gene. It is possible. You would get a 50% chance of homozygous black in each foal, or a 50% chance of it being the same as the mom again, where it's a hidden red carrier. Easiest way to do that, test. UC Davis has a red factor test. Animal Genetics has a red factor test. There are options out there. But again, I personally don't believe that it matters. I don't care. Red's red. Alright, so going back to the eraser. So we've discussed the fact of dominant alleles, dominant being black, recessive being red. Every horse this is considered a base. This is the base of the painting. This is the gesso you put on down before you start painting. This is it. This is what you're putting onto the canvas. This is your base. This is your gesso to smooth it all out. You put down either a black and a black gene, or a black and a red gene, or two red genes. That's what every horse in every breed starts out as, is biggie, 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 little e, little e, little e. Those are your three choices. That's it. Okay? So biggie, 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 little e, little e, little e. There is your homozygous black horse, there is your heterozygous black horse, and there is your red horse. Okay? So, moving along. Now, Percheron people. This is something else that you guys have. You have this beautiful thing called gray. And yes, I spell gray with an E. It can be spelled either G-R-E-Y or G-R-A-Y. It depends on your location and how you were taught, to each their own, okay? So, gray. Gray is a lack of pigmentation in the hair shaft, okay? Think of it in terms of like people. When we are born, we are not born with gray hair. We are born as either blondes, brunettes, black hair. Our hair color starts out as an original color. Horses are the same way. See this base color? Even though that horse is gray, one of these is there. One of these is hiding underneath that gray. Because what does gray do? Gray erases color. It takes away the pigment, the color pigment in the hair shaft. It is the same with human beings. As we get older, we all have gray in us. So our gray takes away our hair color. As I get older, I will no longer be a dark blonde. It will go away. I will end up with silver and white hair, Lord providing I make it that long, okay? It's the same with all people. But in this case, not all horses are gray. That is the difference between us and them and human beings, is that not all horses are gray. To get gray, you must have at least one parent. One parent must be gray. It is a necessity. You cannot have a gray horse out of two non-gray parents. And if you do, then obviously something's wrong. Obviously the stallion that you bred your mare did not breed your mare. It is genetically impossible. Alright, so, but one of the most interesting bits of tidbits that people are most interested in when it comes to gray Percherons is, how many copies of gray does my Percheron have? Now, most people here in the United States do not like to breed and raise grays. We do have them. It is the second most highly registered color in the Percheron breed in the US. But people love their blacks. So, we will take... Let's take Nate, for example. Rolling Hills Nature Boy. Now, we know Nate's sire was a gray stallion, okay? I do know for a fact that Nate's sire was a one-copy carrier. Why? Because if I remember correctly, Nate's sire has a black parent. So, when you have a black parent, You cannot get a copy of a gray gene from a black parent. It does not happen. It cannot occur. But because one of Nate's parents, Nate's parents was gray, Nate's sire had a copy of a gray gene. Okay, so we'll take this for example. Now, if I remember right, Nate's dam was a black mare. Okay, so she carried absolutely no gray, being a black mare. So when you take a horse like Nate here, you take Nate's parents, you paired them up, which I remember seeing his sire MGLI years ago. You pair up Nature Boy's parents, okay? So Dad passes on his dominant gray gene. Mom passes on her non-gray gene that does not exist. Dad passes on his dominant gray. Mom passes on her non-gray. Dad passes on his non-gray gene that he does carry. Mom passes on her non-gray. Again, the same. So when you take a horse like Nature Boy, and Nature Boy is created, he was one of these two of the 50% chance of getting gray. Nate came out gray. So we know that Nate carries one copy of gray and one copy non-gray. Nate is heterozygous, meaning that Nate can produce non-gray foals, providing he is not bred to gray mares. You do not breed him to gray mares if you want to get away from the gray gene. You like the horse, you want to breed to him, you can use gray horses. Again, it's just like using chestnut horses. If you have a damn nice gray horse and you want to use it, providing that one of its parents was non-gray. Look at your paperwork on your horses. If you want to get away from gray genes, do not buy horses that have two gray parents. If you want to breed grays and you don't care, be my guest, okay? So I'm trying to make this as simple as possible for people to understand that, this is how gray works. To get gray, one parent must be gray. Again, these horses will start to carry all these copies. So even Nate himself, we could get more elaborate. We're not going to. These horses carry. We know Nate is heterozygous. Nothing wrong with that. Again, you can utilize a horse who is heterozygous black, red carrier, use him on non-red carrying mares and get perfectly nice black babies and gray and black going gray babies. It is more than possible. Use the horse. Don't be foolish. Don't get rid of him. Don't dump him. Don't do stupid stuff. Utilize the horse. Because it is dumb to cut off your nose to spite your own face by culling out perfectly good genetic horses so that you can get away from things you don't like. There are ways to get away from things you don't like. It just takes a little patience and knowing what you're using in your breeding program. So that pretty much explains. We've discussed obviously our dominant alleles, our base coat, our base colors, which is black, heterozygous black, recessive red. We have discussed a Gouty now. We discussed a Gouty, how a Gouty works. What it is a Gouty determines how the black hair is distributed on a horse. It only shows on black based horses, so it can only show on a homozygous black or a heterozygous black. It cannot show on red because there is no black pigmentation in the hair for it to control. So it is essentially a hidden gene in a red horse. A lot of your horses like Bambi, they descend from those horses. Back in the old days, the old chestnut Percherons carried the agouti genes, and the agouti genes stayed hidden on the red horses because the red horses had no black to help it come out and show until they were bred to black Percheron stallions, and then they got, guess what, bay horses. It's kind of similar to what goes on in the Belgian breed. A lot of the Belgians carry hidden agouti genes, be it in heterozygous form or homozygous form. They do carry the agouti genes, and when they breed these horses, cross them out onto Percherons. That's why a lot of your Percheron Belgian crosses are bay horses. Not all Belgians, but quite a few of them do carry agouti. Now, we've discussed a Gouty. So a Gouty is bay. We've talked about that. We've talked about gray and how gray occurs, that there is such thing as dominant gray, which is homozygous, where a horse will do nothing but produce grays. It has to have 2 gray parents. There is also our heterozygous gray, which is a 1 copy of gray. These horses have a chance of producing non-grays. This is what I use in my breeding program. If a horse is gray, I'm not going to discredit it. I like gray horses. If I get the color without the gray, super awesome. If I don't, I don't, okay? So I will use 1 copy gray horses in my breeding program. I will not use, though, a chance of any horse that has 2 gray parents. I will not buy into it. I don't want gray to hide what I have. You know, I'm trying to raise blue roans, I'm trying to raise bays, I'm trying to raise everything. Gray is not my sole focus, so I stay away from homozygous grays. I stick with heterozygous grays. Another thing that we discuss, brown and bay are very similar. There's been no genetic proof. At this point, they thought they had a test for it. Some of the tests was coming back with inaccuracies. They haven't been able to prove yet at this point the difference of brown and bay. We do think that there's obviously visually a difference. Typically your brown horses are darker in the body color. They're not as bright mahogany red as you see your bays. They tend to be quite dark in winter where they're very, very dark brown, and they'll have like a mealy reddish muzzle or flank area. Those are typically your browns. Your horses, you think like back in the thoroughbreds, what they called a black bay. They do this in Arabians as well. They are such a dark color that they look almost black, but yet they'll have a reddish tone to the muzzle and flank. Those are brown horses, but we pretty much at this point in time we lump them all in the agouti category. Bays and browns are lumped together. The genetics work the same at this point, in which black pigmentation is restricted to the legs, the mane, the tail, around the ears. That's what agouti does. Gray obviously is what occurs there is when the pigmentation in the hair is taken away. Whatever the horse started out as, whether it was black, whether it was chestnut, whether it was bay, whether it was blue roan, it does not matter. If gray is present and in that horse, it is going to erase and take away your color with time. Some grays gray out faster. I've seen foals that are like my filly, like my mare Lorelei, like her daughter Lexi. It's hard to describe. A lot of people ask me, is that a blue roan mare? And I have to go, well, no, she's gray. Why do I have horses that gray out at 3 months of age? I don't know. I haven't figured that one out yet. It hasn't really been looked into. I kind of am curious about it, but then why do I have horses here? Like, for example, I have Etta out here. Etta is 3 years old, and she just has a couple sporadic white hairs in her body, and that's it, and in her mane and tail. She is going to take forever to gray. I mean, I look for her to be maybe dappled by the time she's 10, 12 years old. She might be white at 20 if she's lucky. And then there's other horses that they gray faster, some gray slower. So we've talked about black, we've talked about agouti, we've talked about gray. Let's discuss red real quick. Red is always the recessive version. It is recessive, it is red, it is present. When you have red horses, and this is why they do this in your Belgians, they breed red to red, and it is always little e, little e. I don't even have to draw the Punnett square. You guys know this. E to E, E to E, E to E, E to E. You have a 100% chance of producing red horses. Red to red always produces red. It doesn't matter if that horse carries agouti. It isn't going to affect anything until you reintroduce black. In the Belgians, the chances of them doing that are about slim to none. I only know of a few Belgian horses of non-Brabant breeding that are black carriers. Those usually descend from out west bloodlines. But for the most part, when you breed red to red, you have a 100% chance of red. Another discussion, roan. Everybody is interested in roan. Roan is very similar in the fact that you have to have a parent present. A parent must be roan to produce roan. A lot of your roan horses over the years, tons of them, were bred to gray horses. I don't know if it was a matter of the fact that it had to be. It had to be. So many people don't understand color genetics. You know, we've come through leaps and bounds here just in the last, 20, 30 years in our understanding of what, color genetics is. And I mean, they were trying and they had a general idea, but a lot of people do not understand how it works. So when they see white hairs, they think that this roan horse is they think that this roan horse is, whoops, that's not what I wanted to do. They think that this roan horse that has white hairs is a gray horse, and it's not. That's not how it is. This roan horse is not gray. It's genetically impossible. This filly pictured here is Luna. Luna, when she was born, she had so much white hair in her body. You can see her black stockings. It's not always lucky like that, though. Sometimes, a lot of times, your blue roan foals, when they're born, they're so black you can't really tell. It takes you about a month to tell. By about a month, you should be able to split hairs, and you can start seeing white hairs in the body. They always have what I call the white crack. A lot of times that will show up first, white in the flanks. Any of the whorls on the neck, you will see white hairs showing up in there first. But it's hard to discern when you involve things like gray, for example. Let's take Lorelei, for example, as a foal. Lorelei was very obviously cliche. She had the gray goggles. This was something that was cliche and easy to see on Lorelei as a foal, and we knew that she was gray. I mean, we knew it was obvious. Not all gray foals have the goggles, but as you can see, when you looked at Lorelei, you could see this hue to her body. She has distinct black, dark stockings, and yet she has all this light white hair coming up into her body, and that is what makes it weird about horses like Lorelei, because Lorelei was such a just odd. She was an odd baby, and I could never explain her. Her daughter, Lexi, is the same way. When Lexi was born, Lexi did not have the white goggles, but Lexi was very funky. She had a lot of white hair. I could already see white hair in her forearms and stuff. You could already see it. It was already there. It just made no sense to me. It's like, how can I have this foal that is going to be so white? But with roans, that's one of the hard things. If you're going to breed blue roan horses, the easiest bet for you would be to stay away from using gray horses in that breeding program. The reason why is because roan involves white hairs, but it is not the same as gray. That's where people mistake it. It does not work the same. A roan horse will be born typically black. We're talking blue roans here. We're not going to talk red roans or bay roans. We're going to simplify this down. Blue roan horses, black based horses with roan present. This horse here, for example, this was Deuce, actually. Deuce is a foal. Deuce was very dark. Like, you can't even tell. You people cannot even tell that that's a blue roan colt unless I just told you, which I just did. Now, Deuce was so dark that there was no signs of him being roan, except for when you would sit and split hairs up by his whorls and his neck, under the armpits, he would start showing white hairs. He would get the white crack later. It started showing up, but again, it doesn't show usually till they're about a month of age. But by the time these foals shed, and let me see if I got pictures right available here. I don't know if I do. I don't think I do. But when they are starting to shed out at 3 months of age, those foals will start to roan out. Here we go. We got the boys. Okay. When those horses start to roan out, for example, here on our boy Suede, they start to roan out, the white hair comes in. You can see this colt was shedding out just black. He was just a black colt, black mare, black stallion cross. But this colt, his dam's in the back, is the blue roan mare in the back, Cassidy. Suede was a son of Ace and Cassie together. He was homozygous roan, which means he got a roan gene from both his dam and his sire. He was homozygous roan. He did not roan any differently than any other horse. It doesn't change how his roan behaves, but in typical Ace fashion, when you start involving things like gray, this is where people get confused, and I'm going to zoom in a little bit here. Ace babies typically have gray eyebrows. Up high, you can see his gray eyebrows. You can see a little bit of the gray, the roaning into his face. And I shouldn't call it gray because we're going to confuse you. Roaning of the eyebrows, roaning high on the cheek, roaning around the ears. Ace babies roan far into the face. Some of them have darker heads than others. Some of them are more solid and the black stays back farther into the face. Not so much roan up around the ears, not the roan in the brow, not the roan down here or the roan on the cheek. This colt is roan. There is no gray present. But when you people want to try to involve gray, that's where you run into problems, because what gray does is gray takes away color. So this beautiful blue roan horse here with these gorgeous black legs, and he would have this beautiful dark face and this dark mane and tail. That gray with time would start out head first graying the face out. Graying the face. Face would start graying all out first. And then the legs will start graying and the mane and tail. That's why I have a problem when I look at fillies like Lorelei or Lexi as babies, because what happens is that these horses behave kind of similarly to roan, and so I haven't been able to prove that yet. I may never be able to prove that, but yep. So that is my color genetics explanation for today. I guess real quick we should go over roan. Roan is very similar. Again, you have to have a roan parent present, capital R, little r. All roans, all blue roans and Percherons right now are this copy. They carry only one copy of roan and one copy of non-roan. My parents are breeding roan to roan. So what is occurring there? For example, we will take, say this is Cassie and say this is Ace being bred together. Here's Cassie. Here's Ace's copies of roan. When we breed roan to roan, we now up our chances of getting blue roan to 75% instead of a plain 50. We up our chances of getting roan to 75%, but of that 75% chance, 25% of that chance is homozygous roan. And when you get homozygous roan, that horse right there, that big R, just like homozygous black, it will always produce roan on every foal you breed. That is the goal. That is the money maker. Roan. So, but I hope you guys enjoyed this. It just was something simple and to try to explain to people and help people understand. I know a lot of you usually have questions. If you ever have any questions, feel free to message me. Feel free to call me. Anything. I love to talk color genetics with people. I love to talk horses. So greatly appreciate you guys watching and have a great day. Bye.